Welcome to KK Tech. In this video, we will talk about what is LiDAR, why it is used in iPhone and iPad Pro, LiDAR on the moon, scientific observations from it, from Apollo to Mars, retroreflectors on Mars, applications and usage of it today, and how it will revolutionize in the future. Do you know what is LiDAR? LiDAR is not a word, it's an acronym. LiDAR stands for Light Detection and Ranging. The name itself explains the fact that LiDAR is a sensor which sends the pulses of light and detects the time taken by the light to come back and measures the distance between the object and the sensor, that is called ranging. We have this sensor on remote sensing satellites, drones, professional equipments, etc. And now we have in iPhone 12 and iPad Pro. How the LiDAR technique works. LiDAR technique uses lasers or infrared light beams to measure distance accurately. By taking the time taken by the light to reach the target and return to the transmitter, it maps the surrounding in 3D, and enormous pulses of light is emitted to map the world in 3D. Usually from a plane, sends more than 4 lakh pulses in a pattern and detects it to form a map. So why it is in iPhone 12 and 13 Pro and iPad Pro? In iPhone it is used for augmented reality and remove the surrounding structures and objects for projection. iPhone 12 and 13 Pro and iPad Pro have apps which enables to scan the room and objects or surface and convert them to CAD model or measures distance between the object. Apple says it will be used for imaging by utilizing it for autofocus to night, and it also helps to get correct color saturation through the whole image, that is background and the subjects captured are in real life colors. This is not a new technology, but it has gone a long way of R&D and has its application on consumer products. Apple is always years ahead in smartphone technology, but we can expect this technology to be used in other phones in coming years. This will revolutionize us with a big leap forward in augmented reality. We have already seen Microsoft HoloLens using this technology in the map with the entire surface of the surrounding of the user and project augmented reality. LiDAR on the moon. How do you think NASA measured the distance between the Earth and the moon? It all started way before Apollo 11 in 1962. The first successful lunar ranging tests were carried out in 1962 when Louis Smolin and Giorgio Fiocco from MIT succeeded in observing laser pulses reflected from the moon's surface using a laser with a 50 joule with a 0.5 millisecond pulse length. Before starting, let's know about reasons for using retroreflectors. Previously, it was possible to bounce off light or radio waves on the moon to measure distance. This is called Earth-Moon-Earth communication, also known as EME or moon bounce. Is a radio communication technique that relies on propagation of radio waves from Earth-based transmitter directed via reflection from the surface of the moon back to Earth-based receiver. Moon's surface scatters light, which affects accuracy, so by adding retroreflectors to this process and lasers created a LLR or lunar laser ranging experiment. The advantage of retroreflectors is the ability to reflect light back to its source. A retroreflector, sometimes called retroreflector or cataphote, is a device or surface that reflects radiation, usually light, back to its source with minimum scattering. Here we can see examples of retroreflectors. If you have seen a bicycle with a glowing stickers or something, it is basically a retroreflector. In right side there is a gold corner cube retroreflector which reflects light back to its source. But when the LiDAR experiment went to the moon, Princeton University graduate student James Fowler proposed placing optical reflectors on the moon to improve the accuracy of the measurements. This was achieved following the installation of retroreflector array on July 21, 1969 with the crew of Apollo 11. Later, Apollo 14 and 15 also carried these retroreflectors, and Lunokhod 1 and 2 missions from Soviets also carried them. Here you can see retroreflectors of Apollo 11. Also here in this image, Apollo 11 astronaut Buzz Aldrin carries two components of early Apollo Scientific Experiments Package EASEP on the surface of the moon. The Passive Seismic Experiments Package PSEP in his left hand, and in his right hand is the Laser Ranging Retroreflector LR3. So, what are the scientific observations from it? According to NASA, when Apollo 11 landed on the moon, the crew brought devices with them called retroreflectors, which are essentially small arrays of mirrors. The plan was for scientists on Earth to aim lasers at them and calculate the time it took for beams to return. This provided exceptionally precise measurements of Moon's orbit and shape, including how it changed slightly based on Earth's gravitational pull. From Apollo to Mars, research with these Apollo-era lunar reflectors continue to this day. Scientists want to perform similar experiments on Red Planet, and NASA's Perseverance rover landed on Mars on February 18, 2021, carried laser reflector array. There is also a small one aboard the agency's InSight lander called Laser Retroreflector for InSight. Here you can see Perseverance rover with its retroreflector. Retroreflectors on Mars visible near the center of NASA's Perseverance Mars rover. This illustration is the palm-sized tube called the Laser Retroreflector Array (LARA). In the distant future, laser-equipped Mars orbiters could use such a reflector for scientific studies. Perseverance was built and is operated by NASA's Jet Propulsion Laboratory, a division of Caltech in Pasadena, California. Retroreflector was provided by Italy's National Institute of Nuclear Physics, which built the instrument on behalf of Italian Space Agency. For becoming future ready, NASA says while there is currently no laser in the works for this sort of Mars research, the devices are geared toward the future. Retroreflectors like these could one day enable scientists conducting what is called laser ranging research to measure the position of rover on the Martian surface and test Einstein's theory of general relativity and help make future landings on Red Planet more precise. Applications and usage today. LiDAR is applied in many fields that starts from a food. In agriculture, LiDAR can help determine where to apply costly fertilizer. It can create a topographical map of the fields and reveal slopes and sun exposure of the farmland. LiDAR is now used to monitor insects in the field. LiDAR is also helpful in global navigation satellite system denied situations such as nut and fruit orchards where foliage blocks satellite signals to precision agricultural equipment or a driverless tractor. LiDAR sensors can detect the edges of rows so that farming equipment can continue moving until global navigation satellite system signal is re-established. This is an example of LiDAR instrument used for surveying today. Besides, it is used in archaeology, autonomous vehicles, etc. Another important application is in LiDAR speed gun. LiDAR speed guns are used by police to measure speed of vehicles for speed limit enforcement purposes. Additionally, it is used in forensics to aid crime scene investigation scans of scene and are taken to record exact details of object placement, such as blood, etc., and other important information for later review. These scans can also be used to determine even a bullet trajectory in cases of shootings. Few military applications are known to be in place and are classified. Others are in mining, physics, astronomy, robotics, space flight, and surveying, etc. How it will revolutionize the future. Humans are unpredictable, and application of this may vary greatly as it will be accessed by millions of users who are creative and innovative. We have already seen some apps for using LiDARs inside iPhone, which have various applications. HoloSense will be a predecessor to a whole new world of products like VR headsets with LiDAR sensor to know and adapt according to surroundings. We can even expect AR headsets with LiDAR on it, which we can even have a virtual classroom or meeting room or even used for many devices which enables to do important tasks. If you want to see more videos like this, subscribe to my channel and like this video. Thanks for watching.